counted as a healthy.
Yeah.
All right.
Alright.
Hope you brought enough for everyone.
Where did Blake and Colin go?
Colin has a
Big Blake
big
and
eye.
Really?
Something died.
His car died?
Blake was here.
Let's take a moment of silence.
No, he's died. It was Ewing, so I don't know who died.
It's like incredible.
Wait, someone actually died?
Yeah.
Yes.
Not his car.
I don't need this. So, well, I guess now we're losing faster than we're gaining.
Nope, we're good.
Double time, Wheeler. Let's go, man. Get that race walk on.
Oh yeah, look at that form.
Sponsored by Muscle Milk.
Oh, I tried to kick the.
Third time's a charm.
No. Failed twice and I'm going back.
All right, so this isn't going to explode, is it?
No.
I
No.
thought for sure when I picked it up it would weigh about a pound. You're on it.
Yeah.
No, that'd be about like that big. I did find like a thing that you can buy like 5 times. Like,
Box! Oh, I know.
what? Guess.
It's a cubic lattice demonstration unit.
Yeah.
Yeah.
This?
That
Oh,
was
that would be good.
Wow.
He would be for me.
I didn't even know those existed. That would have been a whole lot better gift.
Yeah.
Hey, you can't. Come
I
on.
don't know who Andrew Robertshaw is.
I wonder.
Andrew Robertshaw. Oh,
It never stops.
it's one of those,
Yeah, gifts.
it's a Russian doll thing.
Oh, I know
Guess what it's made of?
Is it made of pewter?
Yes, it is.
Wait,
Peter
let me
Bear
see.
with a hat.
Peter Bear and that.
Is it really a bear?
It's a
It's
Peter
really
Bear
fair.
with a
It doesn't
hat.
look like a bear. It's like a.
That's- That reference is old, but it checks out.
Reference game off. Holy.
Bear with that. It's very nice.
Did you just make
Well
that up?
Happy holidays.
I mean, like, did you just like come up with that now?
What?
Finals and all.
It's an old reference.
That's an old reference, but checks out.
It's from Star Wars. It's an old film. It's an older
I mean,
film.
it's
It's an
an
older
older
film.
Is it what?
Star Wars. It's an older film, sir, but it checks out.
Oh, yeah. It's very nice. All
Uh,
right. Now then,
Now,
It's
what
so
were you-
small, I was expecting
it comes
more.
with a cubic display case.
A cubic flat.
Right, an FCC display case. Okay, so,
We
thank you
put
very
one
much.
of those on each face and we FCC face it. Each face.
Anyway. What questions do you have about material science? I didn't give you a review sheet for electronics. I guess I could probably pull that together, but I figured it's only one. Would you please? One
Review for the final.
chapter.
Would you
One
please?
chapter? I think it's only one chapter, right?
Is
Yeah.
it,
Well, in my book, it's 2, so.
is the test just 7 questions? Again, like normal?
Yeah, 7 questions plus a short answer-ish kind of page.
Oh, like the terms and stuff.
Yeah, terms and. yeah,
7 questions?
7 problems and then a short answers page. So there's 8 total pages, 25 points apiece.
So we have to do all of them.
You have to do all of them. This is not like thermo, this is,
Are we working under the assumption of the 80-90-70 scale?
well, I'm gonna go with 90, 80, 70, but yeah.
What did I say?
80, 90, 70.
Okay.
So an 85 is an A, but a 92 is a B. Apparently in Clayton's universe.
Well, that would be awesome with my grades right now.
That would, yeah.
Anyway, so yes, it's a straight 90, 80, 70 kind of thing.
Yeah.
There's not really.
And still,
you
and
need
just
to
the
curve these things.
2 hours.
Just the 2 hours. It's the same length as the other exams have.
Yeah.
So that means like a 35% curves up to a 70.
What?
You said 90, 80, 70, so.
Oh, I see.
What is
90, 70, 60 is what I meant to say. I'm sorry.
is that? Just like the grading
Right,
cutoff?
90% is an A, you know, the cutoff for an A and B. Yeah. So basically uncurved, it is uncurved. I think it covers the whole semester. What's that?
What if you just do horrible all across the board, would you curve it?
No. I think I have enough history with this one because I taught this class several times at IIT. So I'm pretty confident.
In our abilities, or in the fact that we
I'm pretty
all-
confident in the effectiveness of the exam in gauging student aptitude. The,
Well, that's two different.
so anyway, and there will be 2 questions from the electrical section, since that was not tested separately.
Are you gonna email us the equation sheet?
I should, yeah, I was thinking about doing it this, last night or the night before. I was looking at it and just forgot, so yes. I will be particularly effective at remembering if someone sends me an email. So,
Do it now.
anyway, but yes, I will send you the equation sheet. And the equation sheet, really the equation sheet hasn't changed much. I put Planck's constant on there because now we have, you know, H. Really, you don't know?
I'm doing anything, H.
I talked about the energy of a photon was H nu. When we talked about photoluminescence, yes, I did. Somebody back me up. Seriously, nobody in here remembers me talking about the fact that the energy of a photon is H nu when we were talking about photodiodes and photoluminescence.
I think it was a brief side note,
Okay.
but it was a brief note.
The assumption was, you've had modern physics, I shouldn't need to tell you this. So, anyway, that's one of the fundamental things in physics you need to know.
Not everybody says.
The assumption is that we retain
What's that?
100% of our
They have
physics class.
Oh, really?
I
Okay,
haven't taken
equals H nu. If you need that, I'll put it on the test. How about that? But anyway, so I didn't really change the equations much, but I did add substantial, like 2 more tables. Because there's electrical properties now.
Semiconductor equations that we had on like EG divided by
Yeah, I don't know if I put that on there or not. You need to know that sigma equals NQ mu.
You know what you should do, Dad? You should have a deal where you can't bring any like equation sheet or anything of your own, but if you're willing to get it tattooed on yourself, then you can bring that in.
No deal!
I've got henna, guys.
I do it, huh?
Anyway. Okay, so if you're gonna go henna, it has to be on your face. I'm just saying.
How are you gonna see it then? You come in with henna and a mirror?
That's good.
You have to do it, you have to do it
write it
reverse
backwards.
then.
Oh, we're digressing terribly.
I love it, it's the
Anyway,
last day.
so the main addition to the equation sheets is the electrical properties. So the whole table of semiconductor mobilities and that kind of thing, and gap energies and all that kind of stuff. Okay. Otherwise, that's the only new material, but that's why it gets 2 problems in the test.
If we come by your office, can we get our old tests?
Yes, same answers I gave you Wednesday when you asked the same question. It may not have been
We
you,
don't-
it may not have been you who asked the question.
We didn't see
Somebody
that
has.
Wednesday, did we?
Not it.
No, we didn't meet on Wednesday.
Well, then what was, I think it
It
was
was
Blake.
Thursday, I asked about a thermal testing.
Oh,
Thursday.
sorry.
See, even you bleed over in between
Yeah,
classes,
yeah,
so
yeah,
don't
yeah.
get on that.
You have a question? Yes, sir.
So
Third class.
the finals is gonna be like questions that were on, not the
No,
same questions?
no, not the same questions. Not at all.
The same?
Not at all.
Topics.
Yeah.
I mean, same material, it's the same one.
So it's the whole semester?
The whole, it is comprehensive. It is a comprehensive final exam. And the best way to review for it is probably to go back over the, review sheets that I gave you. Because I hate to tell students to go study a former exam, because the tendency of the students then is to, say, oh, I know how to solve that problem, I'm good for that section. Which is not at all the truth, because each problem can only represent a small portion of the section. So, I recommend you not use the previous tests to study from, but rather go back through the review sheets that I gave you, make sure you know all that.
So it's likely for you to pick types of problems
that were not on our tests?
No, not necessarily. Really, I mean, it's not,
You're
no,
reading
I'm
too
not
hard
trying to,
into
I'm not
this.
trying to be, you know, one way or the other about it. I just went through, and honestly, when I picked the problems for the final, I did it independent of the other exams. So, for all I know, I may have,
They're all the same.
I don't think I picked any problems that are exactly the same, but,
So you couldn't see.
right, so, you know, when we talk about crystal structure, I'm gonna have probably some kind of a problem about crystal structure, right? Because that's a fundamental thing. You have crystal structure problems on your first exam, you're gonna have more of them now. There's gonna be a phase diagram or a TTT diagram kind of a problem, just like there was in the other one, but it won't be the same problem.
Yeah. But does the same thing go about the hexagonal flow test?
What same thing?
Well, we said, you said that would not be on the test.
Yeah, so, yeah, I'm not gonna make you draw or, you know, work out directions and stuff in HCB. Because it's complex enough that if you walk away knowing how to do the cubic system, you can figure out the hexagonal if you need to. But you still need to know what HCB is. I'm not gonna make you do the highly analytical problems with that. What else? What other problems, questions, things you'd like to discuss?
Regarding thermal?
This is a long class for that.
You didn't show up.
Yeah, it's late. It is 2 hours, there was not an extra hour added.
That's correct. Everything's 2 hours. But on the thermo side, the exam is often curved. Here it is not. Because the thermo side is really, there's some really involved problems, whereas here, you either know or you don't know what kind of stuff. So it shouldn't take you more than 2 hours for this.
Yeah.
Is this like Christmas sweater day? Because is there like a particular, did your wing do this, or is it just everybody?
It is silent night, so.
Yeah, but usually that's a little more than just a Christmas sweater.
There was a dude dressed up as an elf in my chemistry class.
Really?
Yeah.
That's nice.
Buddy.
Was his name Buddy?
It was a Buttermilk costume, yeah. At least I saw a Buttermilk costume in KSAC.
All right, I'm not going silent night, so.
Uh,
Because I'm
It's
an
a
old
lot
prodigy old man. It's date night.
Oh.
I really don't like sacrificing date night for, you know.
I respect that.
Yeah, it's
The,
fun
the
night.
silent night started at 7 o'clock. If I could show up at game time and go to silent night, I would. But since you can't, and you have to be there at 5 o'clock, I'm not sacrificing that. We went one year. You know, we had the thrill, and
Yeah, I don't get why we have to be there at 5 o'clock.
I don't know.
There was
I know you have to be
people-
there at 4:45.
There was people lined up at the door at 1:30.
We're gonna send the freshmen on your way and you go.
1:30.
Yeah, I'll just stand on the.
Doors don't open
court.
until 4:30.
I don't care.
Actually, it's like
4:45.
you end up like 6 behind like 8.
All right.
I don't care.
We're really not talking about materials here. Dan doesn't like any of this stuff either. You know, 10 years from now, somebody's gonna take this class as an independent study.
You're very confused.
Why are you calling me Dan?
Should we explain it now?
No.
Yes, it's very end
No.
of the course.
No. Yes, sir.
It's not about the test, but when I was in chapel this morning, I was wondering what wax is. Is that a composite?
What
Or
wax
polymer?
is? It's a
Yeah.
polymer.
It's a polymer.
It's a polymer. It's a low molecular weight polymer. So if you polymerize wax more, it becomes hard plastic. So waxes. I mean, there's not just one thing that's wax. Right. So wax is a short chain polymer,
So then,
relatively short chain.
how do you get, like, is the different scents of wax, is it based off of what material you use, or is it just you add scent
Yeah.
into
Usually that's
the
it.
wax? Okay, okay.
I can understand.
Quit trying to sound smart,
They put
okay?
they put little pine trees, interstitial pine trees.
Interstitial pine trees.
I believe they occupy the tetrahedral interstitial site.
So would those come off of the branches?
Go ahead.
I was just gonna ask what scent is.
What scent is?
Yeah.
Scent is an aromatic, it's a molecule, it's a single, I mean, they are multiple molecules, but they are molecules.
Scent is really the way that
That
you're.
we detect
That we process those
molecules
molecules?
present in the air. That, however, is an organic chemistry question, and this is material science. So,
But everything crosses over, right?
Yeah.
That's
Just says you'll learn that in another class.
What else? Seriously, do you guys not have any questions? Or, yes?
I would like to go over Schmidt factor stuff.
Schmidt factor?
Yes.
Okay. Let's go over Schmidt factor. Like, man, you're such a buzzkill. All right. Is that right?
Close enough.
We
I think
can,
it's
whatever.
just gonna be
I think
Yeah.
it's a T.
Yeah, there's a T at the end.
Schmidt factor.
What?
He's speaking French.
Pizza the Hut.
You ever had a better class?
Yep.
Turning the knife.
Oh, then they, I don't think Schmidt factor's in this back
Fine,
end
we'll
here.
take our
Okay.
nice pewter bear gift back.
Dynamic.
Okay, so we're trying to find the resolved shear stress. Right, so we have a sample. Pulling on it. And so there is a particular slip plane that's going to, that we're considering the Schmidt factor for. Right, now, here's the slip plane. So this is the, you can imagine this might be, if I kind of try to draw this as a close packed plane. Okay, that's, and I just can perpetuate, right? So those are the atoms of a particular close packed plane. Let's say it's FCC. Okay. So I have this plane, and I know that that's the one on which the dislocations are most likely to propagate, because that's the one where the atoms are closest together, so it's easiest to slide things past one another. And then beyond that, there is a particular direction within that plane. So this arrow is in the plane of that. It's on that plane, right? This arrow is in that plane. Where the slip is likely to occur. Let me not draw that one because now that's going to be confusing because it's in the direction of mine. Let me draw this one. Okay. So there are two angles that we're concerned with, and I can't remember which one was theta and which one was phi. So you'll have to just bear with me. So that's a right angle to the plane. That's the direction that defines the plane. It's the plane normal. So there's an angle. Again, I'm going to get theta and phi backwards because I can't remember the nomenclature your book uses. There's an angle between that plane and the direction that we're pulling this thing. And then there's a different angle, phi, between the direction we're pulling and the direction in which the slip is most likely to occur, the close packed direction. Right, so the close packed planes where they're close, where the atoms are going to be closest together aerially, have the closest aerial density, so it's going to be easiest to pull on there. But then the particular close packed direction is where those atoms are even more tightly bound, and so it's most likely to slide in that direction on that plane. So you remember the close packed plane, close packed direction, that concept hopefully. That's really what we're capturing here. Okay. So there's two angles. One is the angle with respect to the direction of the slide, and one is the angle with respect to the normal to the plane. So if, for instance, that plane was the 1, bar 1 plane, then it would also be the 1 bar, this is the 1, bar 1 plane. The perpendicular to that is the 1, bar 1 direction. So you can use the name of the plane to determine theta. Even though theta is between two directions. Theta is always an angle between two directions. the normal to the plane has the same values, the same coordinates as the plane itself. Okay. So then tau is the, well, the Schmidt factor, actually, I don't even talk about tau. The Schmidt factor, then, is the thing by which I magnify or multiply my applied stress to find out the shear stress on that particular, in that particular direction. So the Schmidt factor is just the cosine theta, cosine phi part, where tau is equal to sigma cosine theta, cosine phi. And I went through the derivation in class. You can go back and look at the video.
Isn't it more like tau max equals tau cosine theta cosine phi? Instead of the sigma, you have sigma there, which is not shear stress. It's a
Yeah, but if you look, where is that derived in the? See if I can draw it. I can call you to the picture. Resolve shear stress.
F over A.
179, 180. So if you look at the picture, it's the fact that the areas, it's the area times, they don't do it in here. Oh yeah, well, they sort of do there, at the bottom, page 180, equation 614. We're doing two things. One, we're finding the component of the force that acts in the displacement direction. So the component acting here, F sub D, whatever, is equal to the applied force times the cosine of phi. And then I just realized they use lambda, not phi. Yeah, they use lambda and phi instead of phi and theta. So, sorry. But anyway, so the component of the force acting in that direction. You see it, Josiah?
yeah.
Right? And then the area on which it acts, right? So it's force, I mean, tau is still force per unit area, but now it's a force, now I've deconvolved this into the force in the plane, and I just need to know the area of that plane. So the area of this plane is equal to the cross-sectional area here, divided by the cosine of theta, as I've drawn it here. Yeah. Okay? So now, it is a shear force, because it's a force in the plane divided by the area of the plane, but the F over A is the same applied sigma stress. Yes?
The Schmidt factor is the 2 cosine.
Schmidt factor is just the 2 cosine.
Yeah.
Yes?
Quick question, finding the direction.
I never have students say, slow question. Go ahead.
Finding the direction in the plane is just, when you got the plane with that direction, it's 0.
Right.
Okay. So it could be a number of directions, just pick one.
So, well, there's a particular direction, right?
Yeah.
This direction is going to be the one in which if this is
Oh, the
FCC,
close packed.
then it's going to be a
Right.
110
Yeah.
family of directions. So it's going to be a 110 plane in the 1 bar 0 direction, or
Okay.
1 bar 1. So if it's a 1 if it's a 1 bar 1 plane, then this would be a 110, or that would be one of the choices. 110 would be one of the options.
And we can just choose any of those directions then?
Well, you would typically do it for each of the 12
Oh, and then
possible
find-
combinations and find the one that's the maximum. That's what you typically
Got
are
it.
using this for.
Okay.
Anyway, but you would do the calculation for each of the ones given
Right.
and calculate the cosines using the function, the dot product. Yes.
Can you go over planes, directions, families of planes and directions and all of that briefly?
Okay. Okay.
It's
Slowly.
not very brief. Slow question.
Okay. So we have a cube, and again, the main emphasis here is in the cubic systems. Okay. For the exam anyway. So we have 4 things. We have sites. Well, actually, we have 3 things. We have sites. We have directions. Actually, let me do them in different colors. I don't have green. Okay, let me do red and black. Okay. let me do it this way. So we have sites, lattice sites, then we have directions, and then we have planes. All right, those are the three pieces that we want to characterize for the lattice. So the sites are defined just by the coordinates. So if we make this an FCC lattice, okay, everybody see how those are with all the FCCs? So I'm going to put my origin back here for this. If I want to know this atom, the site for that atom, then I go, this is going to be my X, Y, and Z, or A, B, and C would be the other way to label it. Right? A, B, and C are typically the dimensions in those directions. Then I'm going to go I'm going to go half in the X. So the site for that one would be 1/2. I'm going to go 1 in the Y, and I'm going to go 1/2 in the Z. So the site is 1/2, 1, 1/2. Okay? Does that make sense?
So sites don't get reduced to integers?
Right. Because sites are actual locations. So the quarter, quarter, quarter is the tetrahedral interstitial site in FCC.
Does that get brackets or anything around it, or does it just
No.
get brackets off?
Because no. It's not. And I've got to go back and check the brackets, make sure I'm doing the brackets right, because I don't do this often enough to remember what's a lattice and what's a... Planes are squiggles and round, yeah, the directions are square and the plane.
He started it. It's not true.
It's nice pebbles. Sadly, there are fewer and fewer people who don't even understand the reference.
I get it.
I know, there's fewer and fewer people who do. Anyway, okay, so, does that make sense? The site. We basically start at an origin, and it's how many things have to move. Sites will always be ones or less, yes?
What's the coordinate, like the positives and negatives for that? Because I feel like it was different than, right? Which way is direct positive X? Is it just like that?
As I've drawn it.
Okay.
But it's inconsequential. In a cubic system, it's inconsequential. Right? A, B, and C are all the same, so it doesn't matter. That's why we have families of directions of planes that are so big. So sites are always going to be ones between 0 and 1, because I only define the site within a unit cell. If I went to the next unit cell to define a site, well, that same site exists in my first unit cell, so I would define it there. Does that make sense? Okay. Then directions. Excuse me. Directions then are so let me take a direction that goes through that same atom. So start at the origin and come out through that atom. Everybody got that? So what I would do with the direction is I would figure out essentially what is the trend, how far do I travel in each of the directions. So I still want to 1/2, 1, 1/2. But now with the direction, I do clear the fractions. So that becomes the 1, 2, 1. And now that the fractions are cleared, I can call that the 1, 2, 1 direction. I go 1 in the X, 2 in the Y, and 1 in the Z. Right? So, and if this had been a simple cubic system, then I would have gotten the 1, 2, 1 to begin with, because I count from the origin to the first atom that my line goes through. Right, so my first, if this were simple cubic, I would not have encountered another atom until I got to the one in the upper corner of this next unit cell. and it would have been 1, 2, 1. Does that make sense? Who asked about this in the first place? Does that make sense for directions? And then what we do is we say, oh, but going from this corner to that face center is no different than going from this corner to that face center, or this corner to that face center, or this corner to this face center, right? They're all the same.
And when you say they're all the same, you mean they pass, they have the same like density of
Right, they all have the same perspective, because I can take the cell, I guess I should have gone from this one through that one over there. I can take the cell and rotate it, flipping A, B, and C, and get this to be the same as that. They have the same relative, they're going from a corner to an opposite face center. And corner through opposite face center means the same thing for everybody. Right? Does that make sense? All those directions are the same. So then I have a family of directions, which are the 1, 2, 1 family of directions, which would include this 1, 2, 1, but then if I start here, I've got a, this would be a 2 bar, 1, 1. Right, so that would also include the 2 bar, 1, 1, which is this one right here. I started here, and I went in the x direction. I went -1 in the x, a half in the y, and a half in the z. Then multiply by 2 to clear fractions, I get 2 bar, 1, 1. Both of those are part of the same family. Does that make sense?
What is the standard for putting together the family names? Does it matter? And could we say that
Yeah, it doesn't
2
matter.
bar 1 1 would count also?
Yeah, but generally you use all positive values. So I could call it the 1, 1, 2 family of directions, or the 1, 2, 1 family of directions. They'd be the same. You know, it doesn't matter. I don't know that there is a formal requirement on that.
Wait, 1, 1, 2 would be different though, right?
What's that?
No. Oh no, never mind. No, it's good. It's good. It's good.
1,
We're good.
1, 2 would be going from here up to that face center. Okay. Is that good for directions then? Good. Okay. Then we go to planes. I'm going to have to go back and erase all this. This one, there's that one. I think we're good. Okay, so now for planes, remember the process is a little more complicated. I have to, let's say I draw, I'm going to try to make it a little complicated. I'm going to put another unit cell out here so I have something to work from. Okay, you see that? It's not beautiful because I tried to kind of draw it half baked there, but
I think it is.
okay, I think I got it.
Beautiful.
Okay,
Beautiful.
so what I wanted to do here is I want to go from here to there. See that? So I came from this one to that one. And I'm going to connect there. Okay, so that's some real funky plane, right? Okay? But what I do is I pick an origin not in the plane. There's my origin. And I find the intercepts of the plane. So that in the x direction, it intersects at 1. In the y direction, it intersects at 2. And in the z direction, it intersects at 1/2. So I find all the intersections. Remember this? The next step now is to invert the intersections. So that I end up with 1, 1/2, 2. Follow that?
What
Then-
what exactly does that inverting do? Like mathematically, what exactly is it? I mean, I know it's inverting them, but like, does that
I think it's finding the normal.
Yeah.
Is that what it does?
Finding the normal. It's essentially, if you want to do it, you know, you want to find the perpendicular to that. That's essentially what you're doing.
So it's
the
just
inversion essentially finds the perpendicular. Because again, the plane is defined by its perpendicular. By its
Yeah,
normal,
yeah.
right? And then I clear the fractions. So that becomes 2, 1, 4. So that is then the 2, 1, 4 plane. Remember? And then the family of planes would be the round brackets.
So what if you chose a different origin? Choose a different origin and shows how it would work out.
Okay. You'd have to guess what, you'd have to be able to visualize where the plane crosses for that origin then. So, that's gonna be tricky.
You could do the one.
I can probably choose,
You do the 0, 1, 0 point.
Yeah.
0, 1, 0,
One in the
1.
back of the middle.
This one here? Okay, that's fine.
Yeah.
So it crosses at 1/2, 1, and 1/4. If I invert it, I get 2, 1, 4, and then I don't have to clear fractions. Okay.
Drop the mic.
Good? What else? So 12 minutes.
What story?
You own me for 12 minutes. What are the questions we have in the way of review?
Piggyback rides.
Most embarrassing moment.
No.
Do you like the bear?
That's the like the bear? Yes, I like the bear.
Where do you put it? You like my hat?
Where am I gonna put it? In my office.
Do you like my
Did you
funny
see
hat?
what it said?
I didn't see what it
Says
said.
Is there any possibility we could pass the
Report card day?
Yeah.
Oh, so it's like a kind of a giftception.
Just double check.
Because it's report card day, as if you guys are it's your report card day and you're giving me a gift of someone on report card day giving a gift. It's a giftception. It's a gift.
Not a report card.
Yeah.
Kind of. What's that?
That's not.
potentially pass around quarter of the bear?
That's
Quarter of
not-
the
yeah.
bear.
Quarter of the bear?
What were we gonna call him?
He doesn't say.
Takes a spark.
Pewter.
Is fired.
Pewter bear.
Porter the pewter bear.
Porter the pewter bear.
Or Peter the Peter bear.
Peter
Ah,
the pewter bear.
Pass around.
Porter
Pewter bear.
Is there lead in that? Is it lead pewter? It's like.
I doubt it.
So if I was just
Hey.
saying-
Oh,
Yeah.
hey. Oh, I actually have a question.
Okay.
Is the ABET stuff up yet?
The ABET stuff.
Like the survey?
Valve things.
Oh, I have no idea.
Okay.
I have no idea. I've not heard anything. Guys were in charge of that.
Got it.
And I've not heard anything from them. They put it up around, so.
This is used.
Maybe fluids.
Yeah, you can tell. There's like a little bit of gunk in him. What?
I think that's left over from the process of forming.
He was, yeah,
Maybe
a good
it's
bonus
sand
question.
stack.
How was Pewter the Bear cast? Or how was Pewter the Bear formed?
Porter the pewter bear.
Sand.
No definitive,
Fantastic.
no definitive answer. Seriously, any other meaningful questions?
We have 10 minutes out of our life now.
What's
Nobody asked a question.
what's your favorite way of casting something?
Overhand.
I'm a side sidewinder.
You're kind of like a little diagonal,
Yeah,
yeah.
I'm mostly
45
over
degree.
here.
A little whip in there too.
Little
Yeah.
name.
With a little stick of the hip there at the same time.
Hey, don't get me
I've
started.
never been outside.
Don't get me started, man. In statics today,
What?
somebody asked about the radius of gyration, and to do a demonstration.
You gyrate? Oh no.
Oh dear.
Oh.
Because there's no camera there.
Can we lock Clayton out for the last 9 minutes of class? That's a legitimate question.
Can we what?
Can we lock Clayton out?
Is he gonna come back?
He took his stuff.
No.
didn't he?
I think he's
Wow.
passed out.
What is?
Yeah. Can we make fun of him when he comes out from the class?
You go to the
He is a
bathroom?
little dusty.
No, he walked into
He was a
the lab.
collectible, somebody's collectible someday.
Okay, well then, I guess that'll be it.
So you got a bad report card, you're giving his mom flowers. So
No, it's to the teacher.
You think?
Yeah.
No, it's for the mom, because he's got the report card already, he's gonna show his mom.